In this video, we're going to talk about the derivatives of hyperbolic functions. So I want to look in particular at the derivatives of hyperbolic sine and hyperbolic cosine. So if I want to take the derivative of hyperbolic sine, we are taking the derivative of, and hyperbolic sine is e to the x minus e to the negative x over 2. And the derivative of this, well, the 2 on the bottom is a constant. It's technically a 1/2 that's in front of this function. So that's going to stay there. And on the top, I'll get e to the x, because that's the derivative of e to the x. And the derivative of negative e to the negative x, after doing the chain rule, will be plus e to the negative x. And the 2 is still there. And this is hyperbolic cosine. So this is hyperbolic cosine of x. So the derivative of hyperbolic sine is hyperbolic cosine of x. And that's pretty similar to what we see with regular trig functions. The derivative of sine x is cosine x. So this is the analog of that with hyperbolic functions. So let's do the derivative of hyperbolic cosine. So we are going to get d dx of, and hyperbolic cosine is e to the x plus e to the negative x over 2. The 2 on the bottom is going to stay there, because that's a constant. It's technically a 1/2 in front of this. And the derivative of the top is e to the x. That's the derivative of e to the x. The derivative plus e to the negative x is going to be, after the chain rule, negative e to the negative x. And that is hyperbolic sine. So this is hyperbolic sine x. So that's what the derivative of hyperbolic cosine of x is. It's hyperbolic sine. And that is also kind of similar to trig, except without the negative signs. So the derivatives of these hyperbolic sine and cosine functions are really similar to the derivatives of their corresponding trig functions, just without that negative sign that shows up with trig functions. So if we want to take the derivatives of other hyperbolic functions like hyperbolic tangent, hyperbolic cosecant, we can derive those as needed. So we could do the same types of steps that I just did to figure out formulas for those derivatives when we need them. If we see a problem where they show up, typically what we do is we just look up that derivative formula. If I wanted you to actually derive it, like we did here, I would specifically say so in a problem. And if I didn't mention that specifically, then it would be okay to just use the formula for those. And it's fine to just look those up.